Okay, hi guys, welcome back to QBT. Today is a follow-on video from our previous two videos on force and how it's equal to the change in momentum over time. If you haven't checked those out, then please do. They're listed in the description below. Well worth a watch. But we're going to just follow on from that and talk a little bit more about momentum specifically in a bit more detail in this video. Okay, so let's begin. This is our equation for momentum. Okay, here we've got momentum is equal to mass times velocity. Okay, momentum is in kilograms per meter per second. We know that mass is in kilos, standardized units. Remember, guys, always convert to standardized units. And then velocity we know is in meters per second. Okay, which is great. Now, momentum, you can think of momentum as kind of the force something carries in motion, the energy something carries in motion. The more momentum something has, the more likely it is to continue on its trajectory, okay? And the more force is needed to actually stop it, right? And that's linked to how fast it's traveling. You think about the velocity, right? If something's going quicker, it's got more momentum, harder to stop, right? So how is that relevant to our previous videos? How is that relevant to collisions? How is that relevant to the momentum before and after a collision occurs? Well, that's related to this equation here. M1 V1 is equal to M2 V2. Well, okay, what does that mean? Christos, that's fine, but what does it mean? It means that the momentum before a collision is equal to the momentum after a collision. It means that the momentum is conserved, okay? Conserved means it stays the same. And that occurs in a closed system. Okay, now we say in a closed system because if it's in an open system, then that means that there are areas that energy can be wasted. Okay, and if energy is wasted, if you lose energy from a collision in other forms like sound and heat, then obviously your momentum isn't being perfectly conserved. But in a closed system, and for the sake of your GCSEs and your A-levels, we say that in a closed system, momentum is conserved before and after a collision, which is great. Okay, but for now, what I want to do is I want to talk to you about how you can actually apply this equation in a real example. So take a look at this tutorial video. Okay, so let's take a look at how we might approach this question. So here we've got a collision that's happening between car A and car B, and we've got some information about what's going on before the collision has happened. We can see that car A has a mass of 150 kilos and is traveling at a velocity of 20 meters per second. And we can see that car B has a mass of 200 kilograms and is traveling at 10.5 meters per second. So the things to bear in mind when we're completing this question are that momentum is conserved in a closed system, okay, which means that momentum before is equal to momentum after, and we're going to need that. Okay, we're going to need to know what the momentum is later on. So that's our first step. Right, so let's calculate the total momentum here. Okay, and the total momentum is going to be equal to the momentum of car A plus the momentum of car B. Okay, and we know that momentum is equal to mass times velocity. Okay, so that means that we're going to be doing, for car A, 150 times 200 plus car B, 200 times 10.5. Okay, and that should give us our total momentum before the collision. And I'm just going to plug that into my calculator. I'm going to do it with you guys. Okay, and you should end up with 5,100 kilograms per meter per second. Okay, so that's step one. We've calculated our momentum before the collision. Okay, our total momentum before. Now, that is going to be equal to our total momentum after. okay, over here, which is great, right? I know that information. So looking at this, looking at what's going on after here, we can see that the cars have collided, right? But they're moving as a single unit, okay? And it will tell you this in the question, whether they collide and they bounce apart, whether they collide and they move as a single unit. But in this question, we're treating them as if they've collided and they're moving together, right? And because of that, we now need to treat them as if they are one object, which means their mass is now cumulative, okay? We need to add their masses together to calculate the total mass, okay? So we're going to calculate our total mass because they're moving together, which would be 200 plus 150, which would give me 350 kilograms, okay? So I now have my total momentum after, and I have my mass, and it wants me to find the velocity that this singular object is now moving at. Well, how am I going to do that? Well, I'm going to rearrange my equation, okay? If I know that this is my triangle, I know that momentum is equal to mass times velocity. To find velocity, I'm simply going to divide through by mass, like so, and I'm going to calculate this, and I'm going to say that V is equal to 5100 divided by 350, and that will give me 14.6 meters per second, and that's rounded to 3 significant figures. Okay, so with a question like this, guys, there's lots of steps, as you can see, okay? But the first thing that you need to do is think about what your total momentum before the collision is. Remember that momentum is conserved in a closed system, which means it will equal the momentum after the collision, and then you need to break down the equations dependent on whether the objects are moving as a single unit. Do I need to add the mass together, or do I need to calculate them independently? Okay, I hope this has been helpful. Okay, and hopefully it is giving you more of an insight about how to approach these sorts of questions.
Right.
Okay. Alright, so guys, I hope that explanation helped you understand how this equation is useful in your exams. Okay, just break it down, you know, think about what you need to calculate, think about what the question is asking you. Are those cars, are those objects moving together as a single unit, or are they moving apart? Okay, then you have to think about it differently. But yeah, in the meantime, thanks for watching, guys. You know, please like, subscribe, support the channel, and stay quantum. And we'll see you soon. See you.